Hey everyone, today's lesson is notes number 2 from Unit 8, and we will be taking a look at the different properties of parallelograms. First of all, the definition of a parallelogram is that it's a quadrilateral with both pairs of opposite sides parallel. So don't forget that we use the little arrows to indicate that lines are parallel to each other. So we need to have line segment AB parallel to line segment DC, and we also have to have line segment AD parallel to BC. Okay, so important to note that it has to be both pairs and not just one pair of opposite sides parallel. Okay, now we're going to take a look at a bunch of different theorems describing parallelograms and their properties. The first one says if a quadrilateral is a parallelogram, then its opposite sides are congruent. So we already know that because it's a parallelogram, by definition its opposite sides are parallel, but this gives us a theorem that tells us that not only are they parallel, but opposite sides are also congruent. So line segment AB is congruent to BC, and line segment AD is congruent to line segment BC. Also, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So angle D and angle B will be congruent, and angle A and angle C will be congruent. So angle A congruent to angle C because they're opposite angles, and angle B congruent to angle D. Okay, so in our first example, if we take a look, it says find the value of each variable in the parallelogram. So we're told from the start that it is a parallelogram. So what we know is that opposite sides are congruent. So we know that AB is congruent to DC. So that allows us to say that 16 is equal to 3x plus 4. And so we've got an equation that we can use to solve for x. So take and subtract 4 from both sides, and 16 minus 4 is 12. So we have 12 is equal to 3x. Take and divide by 3, and we get x is equal to 4. The second thing we notice is that we've got a pair of opposite angles, angle B and angle D, and we just talked about that theorem right above. It says if a figure is a parallelogram, then the opposite angles are congruent. So since angle B is congruent to angle D, we can say for sure that y minus 60 is equal to 56 degrees. So take and add 60 degrees to both sides of the equation, and we end up with y is equal to 116 degrees. And that's our final answer. So another property of parallelogram states if a quadrilateral is a parallelogram, then the same side interior angles or consecutive interior angles are supplementary. Okay, so this should sound familiar from earlier this year when we discussed parallel lines being cut by a transversal. AD would be the transversal between AB and DC. And so when we have two parallel lines cut by a transversal, then same side interior angles would be supplementary. So the measure of angle A plus the measure of angle D would have to be equal to 180. Okay, same thing goes with B and C. So we can put some numbers in, for example. Say that angle A measures 110 degrees. That would mean that angle D would be 70 degrees. Angle A and angle B are also same side interior angles formed by the parallel lines that are the other sides. So angle A and angle B would also be supplementary. So that would mean angle B would be 70 as well. And finally, angle C would have to be 110 because it's the same side interior angle to angle B. so they've got to be supplementary. And angle C and angle D are same side interior angles. They have to be supplementary. All right, the last property here in part 5 says if a quadrilateral is a parallelogram, then its diagonals bisect each other. And that means that this diagonal from A to C, just going to highlight it really quick, and this diagonal from D to B each cut the other one into two congruent parts. So this is equal to this, and this is equal to this. But notice what it does not say, that the diagonals are congruent. Okay, only in specific types of parallelograms will that be true. All right, in example 2, we're going to use that last property, that the diagonals of a parallelogram bisect each other, because it says find the value of each variable in the parallelogram. So we have diagonal FH, that's being divided into two equal parts, and GI, it's also being bisected. So that means that 2x plus y from the first diagonal, that's right here, must be equal to 36. So that's one equation, but notice it has two variables in it. So we need a second equation, which would be 4x minus y equals 24, because those are the two segments of the other diagonal. So what we have here is a system of equations, and we can solve this one by elimination. Notice that we have positive y and negative y. So if we simply add the two equations together, the y's will add to 0, and they're eliminated. So 2x plus 4x gives us 6x altogether. And on the right-hand side, 36 and 24 is equal to 60. So take 6x equals 60 and divide by 6, and you get x is equal to 10. Once you have x, then you need to plug it in to one of your equations. Let's choose the first one. Sorry, I have a mistake in there. So take out that y and put in an x. And in that first equation, we're going to plug 10 in for x. So 2 times 10 plus y equals 36. 2 times 10 is 20 plus y equals 36. Take and subtract 20. And you get y is equal to 16. So x equals 10, y is equal to 16. For the last example, we're given a written description. It says in parallelogram WXYZ, the measure of angle W is 50 degrees more than the measure of angle X. Sketch the parallelogram, find the measure of each interior angle, then label each angle with its measure. So the first part is just coming up with a picture. So if we come up with a picture of a parallelogram, with the piece that I underlined first, that the measure of angle W is 50 degrees more than the measure of angle X, says to me that this angle looks larger, so I'm going to give that a W, and then I can go this way for X, and then Y and Z. Okay, and it says that W is 50 degrees more than the measure of angle X. So if we just say call X like A degrees, and we know that if this angle is equal to A degrees, the opposite angle is also equal to A degrees. Now, angle W is 50 degrees more than this angle, so we can say that its measure is A plus 50. And since opposite angles of a parallelogram are congruent, we can also say that this is A plus 50. Okay, you have two choices for solving for A in this diagram. You can add up all four angles and set it equal to 360 degrees because it's a four-sided figure. So the sum of the interior angles would be 4 minus 2, then multiplied by 180. And 4 minus 2 is 2. 2 times 180 is 360. A quicker way to do it is just to work with angle W and angle X, which are same side interior angles. And recall that same side interior angles are supplementary. So you have A plus 50 is equal to 180. So take and add your A's. So you have 2A plus 50 is equal to 180. Keep solving for a. Subtract 50 from both sides, we get 130. So 2a is equal to 130. Take and divide by 2. We have a is equal to 65 degrees. Alright, if a is equal to 65, then that's the measure of angle x. The measure of angle z is also 65. And then angle w and angle y, you can find those measures by taking a and adding 50 to it. And 65 plus 50 will give us 115. So 115 for those two angles. Final answer. Alright, good luck on your homework. As always, email me or see me if you need extra help.